Hello, welcome to Sauras's classes. In this video, I'll be solving some subjective questions from Tomato book. Now, in this question, we have an integer n which is a positive integer and greater than 1 such that 3n plus 1 is a perfect square, and we have to show that n plus 1 is a sum of 3 perfect squares. Now, as 3n plus 1 is a perfect square, so let us take 3n plus 1 is equals to a square. Now, a is not a multiple of 3, because if a is a multiple of 3, then a square should have been a multiple of 3. But here we can see that a square is not a multiple of 3, as 3n plus 1 cannot be divided by 3. So, a is not a multiple of 3. So, a may be in the form of 3k plus 1 or 3k plus 2, where k can be 1, 2, 3 and so on, can be any integer. Now, taking a is equals to 3k plus 1, we have 3n plus 1 is equals to 3k plus 1 square, which is equals to 9k square plus 6k plus 1, or n plus 1 is equals to 3k square plus 2k plus 1, which is equals to k square plus k square plus k plus 1 square, that is the sum of 3 perfect square. Now for the second case, that is a is equals to 3k plus 2, we have 3n plus 1 is equals to 3k plus 2 square, which is equals to 9k square plus 6k plus 4, or 3n is equals to 9k square plus 6k plus 3. This implies n is equals to 3k square plus 4k plus 1. So we have our n plus 1 as k square, 3k square plus 4k plus 2, which is equals to k square plus k plus 1 square plus k plus 1 square, that is the sum of 3 perfect squares. In our next question, we have to show that for every positive integer n, root n is either an integer or irrational number. Now, when n is a perfect square, then root n is an integer. But when n is not a perfect square, then root n can be represented as a rational number p by q, where p and q do not have any common multiple, that is n square, that is squaring root n is equals to p square by q square, that is n is equals to p square by q square. Now, since p and q do not have any common multiple, therefore p square and q square should be relatively prime to each other, that is p square and q square cannot be an integer. Hence, root n is not a rational number.